All right, well, let's take a look at a 3.8 Oldsmobile, and the work order says it cuts out, and the customer is a lot more descriptive. He says that it's erratic, it cranks erratically, it bucks, misfires, stalls, has intermittent crank no start sometimes, that everything gets worse the hotter the engine gets, there are no codes, and he's previously had the module, coils, wires, crank sensor, cam sensor, and spark plugs replaced in an attempt to get this car fixed. So the technician decides that what he's going to do is connect his current probe, and he's to the high current probe to the starter cable, and he's going to synchronize his ignition system off, or synchronize his scope off the ignition system. Now, what I'd like to show you here is a cranking event. We start out with a fairly normal cranking, and then all of a sudden we go and we're running here cranking this engine at about 150 amps or something like that, and then all of a sudden we are well over 600 amps on our starter draw, and obviously this is not going to work well. The cranking speed immediately slows down, and the engine is just basically lugging over, and we'll be lucky if it starts. Zooming in again, we can see these pulses of a normal cranking, and then we see this very high current flow section. Now, what I'd like to point out is what we're looking at here is typically if we hook up a tool to a battery and crank the engine, we see the average cranking current. But that's not really the story. What the starter motor is turning this engine, and every time a piston goes to top dead center, the amount of effort required to move the crankshaft increases. And so that increase is depicted here by these peaks in the waveform. So these peaks represent the piston going to top dead center. Now, again, kind of like back when we looked at the Volkswagen, if we look at when the ignition event occurs, in other words, this line here, it is certainly not at the top dead center of the engine. The piston is going to top dead center for this cylinder right here, and the ignition fires later. It also doesn't fire consistently. Well, something like this occurs while you're cranking the engine. You're certainly going to have a hard time getting it started. The technician really believes that his problem lies in the ignition system based upon the relationship of the ignition and the starter current. Now, it could possibly be a slip timing chain, but experience tells him that the difference from peak to peak in his starter current pretty much represents an engine that actually has compression, and the 600 amp pulses, kind of bear that out because we fired the plug at the wrong time. Clearly we had compression in that cylinder, or we couldn't have created that much of a current draw. So he goes in and looks at his important ignition signals, and when he looks at this waveform, he's kind of expecting to see a real ugly signal coming from the crank sensor, because that's really the sensor that gets the ball rolling when you start an engine. Now, he's kind of surprised to see that he doesn't see a lot of disturbance there on that crank signal. So I would like you guys to take another look at this. Here's our ignition pulse for the cylinder that he's got the ignition sync probe connected to. And what I'd like to kind of point out is that it seems that we have, this is primary current here of the ignition system, we have a whole variety of different dwell times in this ignition system. And clearly not a design function, because when you crank an engine over, the dwell from cylinder to cylinder really needs to be consistent.